All right, I'm going to run through these problems just to go over factoring review. There's a couple things we need to remember. Always remove the GCF first if you can. And other things to note, look for difference of squares. Look for perfect square trinomials. And what else can we remember? Factor out leading negative. Okay, so if the first term is negative, you want to get rid of that negative term. Okay, so let's do these. So we should always question, can we remove a GCF? Yes, we can. We can divide by 8. So this becomes 8 and 2y minus 1. Now this is an exponent of 1, so we don't need to do anything further than that. Okay, GCF, well, 2 and 8 are both divisible by 2. X to the power of 6 and x to the power of 7. You can remove a 2x to the power of 6. And what that does for you is you get 2x to the power of 6. This entire thing just becomes 1 and plus 4x. Okay, so we got to ask ourselves, is there a GCF in this next one? Nope, this is 1y squared, so we can't really do anything with that in terms of removing a GCF. Then the next question we want to say, is this a difference of squares or a perfect square trinomial? And 16 is a perfect square. Y squared is a perfect square. So let's try y minus 4. Y minus 4. And just double check. Y times the negative 4 is negative 4y. Negative 4 times y is negative 4y. Both of those add to give you your negative 8y. So we're good there. All right. Difference of squares, perfect squares, anything like that. Well, p squared can only be p multiplied by p. 1 can only be 1 times 1. So how do we get a negative as that second term? We'll make them both negative. And we can rewrite this one as p minus 1 squared. Difference of squares, I'm clued into difference of squares because there's only two terms. It's a binomial. So if you recall, how do we get rid of that middle term? Well, you take the square root of the first term, which is y. Take the square root of the second term, which is 9. Make one positive, make one negative. Two terms, they're both perfect squares, so this has to be a difference of squares question. Doesn't have to be, but most likely is. So r and r are the square roots of r squared. 2x and 2x are the square roots of negative of 4x squared. To get rid of the middle term, make one positive, make one negative. All right, again, two terms. So I'm thinking it's a difference of squares question. However, 12 is not a perfect square. But what we can do first is get rid of that GCF. So you're left with x squared minus 1. Now we can do the difference of squares. So x plus 1, x minus 1. Okay, GCF time. So let's factor out the 2. So we get x squared plus 9x plus 16. Now, x squared and 16 are perfect squares. But if we were to do that, so x plus 4, x plus 4, when we expand, x times 4 is 4x, so our outer product is 4x, and our inner product is also 4x. Well, there's no way we're getting to positive 9x using 4x and 4x, so it's not going to be a perfect square trinomial. So we've got to try something different. So what else multiplies to 16, but maybe adds to 9? Well, 3 and 6 do. And if you check that one, that will be correct. All right. So there's only one way to get r squared, r and r. Now 10 could be 10 times 1 or 5 times 2. Well, the only way to get to 11 is going to use that 10 and 1 pair. So let's do that. All right. Y squared, there's only one way to get y squared. That's going to be y and y. Now 16 could be 16 and 1. It could be 4 and 4. It could be 8 and 2. Well, if I'm looking, 8 and 2 are probably going to be the ones I want to get to negative 10. So let's make them both negative, and that'll be good to go. All right, this looks like a GCF type question. 3 is a prime number, so let's try and factor that out. So we get 3 k squared. 48 divided by 3 is going to be 16. 16, I think. And 45 divided by 3 is going to be 15. All right. Well, there's only one way to get k squared, so we can start the process there. Now, 15, to multiply to get 15 is going to be 15 and 1, 3 and 5. Now, that middle term is 16, so I'm thinking it probably has to be 15 and 1. And they're both negative because I need to get negative 16k. All right, so first term has a negative leading coefficient, so let's divide by negative 1 just to make that first term positive, which makes every other sign in the trinomial the opposite of what it was. So now we can factor. D squared can only be d and d. 21 could be 7 and 3, 21 and 1. I'm guessing it's 7 and 3 because our middle term's 4. So let's put 7 and 3 in there. It needs to be more positive. So let's make 7 positive and 3 negative. All right. A cubed, a squared, and a. Let's get rid of or factor out an a. We're not getting rid of it, we're just moving it. We're dividing by a. Now we can factor this. Only one way to get a squared, a and a. Now, perfect square, difference of squares. Well, 16. 64 is 8 times 8, and 8 plus 8 gives me 16. So let's put 8 and 8 there. Now this is negative and this is positive. So let's make them both negative, because a negative multiplied by a negative will give me a positive. So negative 8 times negative 8 gives me positive 64, which is what I want. And negative 8 plus negative 8 gives me negative 16. So we're factored here. Of note, you could write this a minus 8 squared, okay, because it's the exact same thing. All right, bouncing all over here. All right, so a couple things to check. Can I divide each term by 4? Looks like I can. And x. So we're going to factor out the 4x, which means 4x cubed divided by 4x is just x squared. Negative 20x squared divided by positive 4 is negative 5x. And 144 divided by 4, I'll have to think about this one, is going to be 36. All right. So we're lucky that x squared can only be x multiplied by x. 36 could be 36 and 1, 9 and 4, 18 and 2. I'm sure I'm missing one somewhere. 9 and 4 look likely to give us a difference of 5. So let's put 9 and 4 there. Negative 9, positive 4. I want it to be more negative, so the bigger number is negative. Okay. Can I remove a GCF here? No, I cannot. This is prime, and that's prime, so it can't. However, 5x squared can only be 5x multiplied by x, and 3 can only be 1 times 3. The question is where to put the 1 and the 3. Well, let's just plug them in. 1 and 3. Well, 5 times 3, my outer product, is 15, and that is 1x. Can I get to negative 14 using 15 and 1? I can. I need the 15 to be negative, which means that's going to be negative and that's positive. Just check your last term. Positive 1 times negative 3 does give us negative 3. So you don't need to include that stuff, but that's your answer. All right, GCF, nope, that's a prime number, so we can't. However, it's nice that it's still 5x and x. Now 8 could be 8 and 1, 4 and 2. Let's try 4 and 2. So I'm going to put 2 and 4 there. So our outer product here, 5 times 4 is 20, and 2 times x is 2. Well, there's no way I'm getting to 14 using 20 and 2. So let's reverse those two. So let's put 4 there and 2 there. So 5 times 2, our outer product is 10. 10x, and our inner product's 4x. Well, most definitely I can get to 14 using 10 and 4. However, they both have to be negative. So I'm good there. Should be putting boxes around my final answers. Okay, we got 4 to go. 4x you could divide by 2. However, this middle term cannot be divided by 2. So we are stuck just trying to factor using combinations. Well, this could be 4 times 1 or 2 times 2. Let's use the 2x and 2x just to give it a go. 6 could be 6 and 1, 3 and 2. Use the ones that are closest together, so 3 and 2. So our outer product is going to be 4x. Our inner product is 6x. Well, 4x and 6x only get me to 11 at most. I need to 10 at most, and I need 11. So that's probably not it. So let's, even if we switch the two numbers, we'll still end up with 2x times 2x. So it's probably not 2x. In fact, let's go to 4x and x, and let's try our 2 and 3 again. So our outer product is 12x. Our inner product is 2x. So that's not going to work. We got one final combination to try, and that's to change this to 3 and that to put that to 2. So 4 times 2 is 8x. 3 times x is 3x. Yes, I can finally get to 11x using 8 and 3. They both have to be negative. Let's just make that a bit bigger. So finally, took a little bit of going over, but there we go. All right, 6x squared plus 5x plus 1. We can't remove a GCF, so we got to just go for it here. So 6x could be 6 times 1 or 2 times 3. Let's use 2x and 3x. Now 1 can only be 1 and 1, which is nice. So 2x times 1 is 2x. 1 times 3x is 3x. Yeah, I can get to 5x using those two. Okay. GCF? Nope. Now 9x could be 9 and 1 or 3 and 3. Let's go with 3x and 3x. 5 can only be 1 times 5, which is nice. So 3 times 1 is 3x. So that is my outer product. And my inner product is 15. Can I get to 12 using 15 and 3? I can if it's more negative there. So that becomes negative 15x. That becomes positive 3x. That's going to get me to 12x. And negative 5 times positive 1 does get me to negative 5. So that is factored. And again, you don't need to show me your inner outer product stuff, but it's useful when you're working through these. All right, last example. So 4x could be 4x times x, or it could be 2x times 2x. 3 can only be 1 times 3. So we can put that in. And let's check the 2x and 2x. Now these are the same, so it doesn't matter whether I flip the 1 or the 3. If this is going to work, it's going to work either way. So check your outer product. So 2x times 3 is 6x, and 1 times 2x is 2x. Well, there's no way 6x and 2x are going to get me to just negative x. So it is not going to be Oh, here's where my iPad freezes up. So I'm just going to cross this out because that's not right. The eraser's not working. So it has to be 4x and x, and then 1 and 3. So 4x times 3 is going to give me 12, and 1 times x is going to give me 1. Well, 12 and 1, again, aren't going to get me to negative 1x. So let's just switch those around. 4x times 1 is 4x. 3 times x is 3x. It just needs to be more negative, so make that negative, make that positive. And we're good. Just in time for my iPad to freeze up.